Welcome to Star Chat, the podcast that explores the wonders of the universe and all its secrets. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. Today, we're going to delve into some fascinating news about black holes, those mysterious regions of space where gravity is so strong, not even light can escape. As we speak, scientists are making new discoveries that are shedding more light on these enigmatic objects. And I'm excited to share two recent breakthroughs with you. First, let's talk about a massive black hole collision that was detected by the LIGO Scientific Collaboration, Virgo Collaboration, and COGRA Collaboration. This event is believed to be one of the largest black hole mergers ever observed, and it's providing researchers with valuable insights into the behavior of these cosmic giants. The merger, which occurred when two black holes collided, released an enormous amount of energy in the form of gravitational waves. These ripples in spacetime were detected by sensitive instruments on Earth, allowing scientists to study the event in unprecedented detail. And what they're learning is helping us better understand how black holes form and evolve over time. But that's not all. Another team of researchers using the James Webb Space Telescope has made a groundbreaking discovery that's shedding new light on the formation of supermassive black holes. They've identified an unusual galaxy, dubbed the Infinity Galaxy, which appears to be home to a young supermassive black hole. This galaxy is unique in that it has two compact, red nuclei surrounded by a ring, giving it the shape of an infinity symbol. The Infinity Galaxy is thought to have formed when two spiral galaxies collided, triggering the collapse of a massive gas cloud and the formation of a supermassive black hole. This discovery supports a leading theory on how some supermassive black holes form, known as the direct collapse hypothesis. According to this theory, supermassive black holes can form directly from the collapse of gas clouds, rather than through the merger of smaller black holes. These two discoveries are just the latest examples of how our understanding of black holes is evolving. And as we continue to explore the universe and push the boundaries of what we know, we're sure to uncover even more secrets about these mysterious objects. So, join me next time on Star Chat as we explore more fascinating stories from the world of astronomy and space exploration. We'll be right back with more fascinating space news on starchat.do. Welcome back to Star Chat. We're diving into the world of space exploration and technology, where innovation knows no bounds. Our last segment took us on a journey through the vast expanse of the cosmos. But now, we're shifting gears to focus on a rather concerning development that could impact our understanding of the universe. You might recall the New Horizons spacecraft, which made history by becoming the first human-built object to reach Pluto. This mission has been a groundbreaking achievement, providing us with invaluable insights into the outer reaches of our solar system. However, we've just received word that the New Horizons mission is facing a significant threat due to budget cuts proposed by the current administration. The implications are stark. If these cuts go through, the New Horizons spacecraft will be shut down prematurely, effectively ending its mission years ahead of schedule. This would not only mean the loss of a remarkable spacecraft, but also the potential discovery of new celestial bodies and phenomena that could have been uncovered with continued exploration. Imagine the wealth of knowledge that could be lost, the questions that might remain unanswered, and the opportunities that could slip through our fingers. It's a sobering reminder of the challenges faced by space agencies and researchers in their pursuit of advancing our understanding of the cosmos. As we consider the potential consequences of these budget cuts, it's essential to recognize the significance of continued investment in space exploration. The benefits extend far beyond the scientific community, with innovations and technologies developed through these missions often finding applications in our daily lives. We'll be keeping a close eye on this developing story, and we urge you to stay informed about the importance of supporting space research and exploration. The future of our understanding of the universe depends on it. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. As we continue our journey through the vast expanse of the universe, we find ourselves pondering the mysteries of celestial explosions. Today, we're going to delve into a fascinating discovery that has shed new light on the enigmatic world of supernovas. Imagine a star that explodes not once, but twice. This phenomenon may seem like the stuff of science fiction, but astronomers have recently captured visual evidence of just such an event. A stunning image of a 300-year-old supernova remnant, taken by the Very Large Telescope in Chile, reveals a double-shell structure that has left scientists abuzz. To understand this remarkable finding, let's take a step back and explore the life cycle of stars. When medium-sized stars like our Sun exhaust their hydrogen fuel, they shed their outer layers, leaving behind a small, incredibly dense core known as a white dwarf. These remnants are about the size of Earth but pack roughly the mass of the Sun. Now, when a white dwarf is in orbit with another star, it can siphon mass from its companion, growing denser and more unstable. Theoretically, this process can lead to a Type 1a supernova, a catastrophic explosion that marks the end of the star's life. But here's the fascinating part. Scientists have long suspected that some white dwarfs might undergo a double explosion, and this new image provides the first visual evidence to support this theory. The team of researchers, led by astrophysicist Priyam Das, observed a supernova remnant 160,000 light-years away in the Large Magellanic Cloud, a tiny neighboring galaxy of the Milky Way. After collecting data for 39 nights over 2 years, they finally had a clear image of the remnant, which showed 2 distinct shells of calcium racing away from the site of the explosion. This double shell structure is difficult to explain using traditional theories of supernova formation, but it can be accounted for by the double detonation theory. According to this model, the white dwarf steals helium to create a highly combustible blanket around itself, which explodes well before the dwarf reaches its maximum mass limit. The ensuing shockwave triggers a second, larger blast, creating the supernova. This discovery has significant implications for our understanding of the universe. Type 1a supernovas are incredibly useful as cosmic measuring tapes, allowing us to gauge the expansion of the universe with remarkable accuracy. But if these supernovas can form through multiple routes, as this study suggests, it may help explain why they shine so reliably. As we gaze up at the starry sky, we're reminded that the universe is full of mysteries waiting to be unraveled. The discovery of this double explosion supernova is a testament to human curiosity and the power of scientific inquiry. So, let's keep looking up at the stars, wondering about the secrets they hold, and striving to uncover the hidden truths of the cosmos. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.